So welcome everybody to a webinar from the Harry R. Hughes Center for Agro-Ecology. Just a little background to those of you who don't know about our organization. The mission of the Hughes Center is to promote environmentally sound and economically viable agriculture and forestry as Maryland's preferred land use. So we are a nonprofit organization that is within the University of Maryland College Park. And we support research, we conduct outreach, and support collaboration to achieve the goal that I just mentioned. And we're really pleased to have today Dr. David Newburn to present his research. Again, as I mentioned, we do fund research, and we've funded Dr. Newburn both on this project and some excellent work that he's done in the past that helped answer questions related to land use and good policy for the state of Maryland. So we're always excited to see his work. And I mentioned this in part also to promote that we right now have a request for proposals out. And if there's anyone here who's interested in seeing that and seeing what we're interested in funding this year, you can go to our website, or Josh might be able to drop the RFP in the chat as well. So please do so. We're looking for great proposals to fund. With that, I want to again thank Dr. David Newburn and welcome him. Dr. Newburn is an associate professor and extension specialist in the Department of Agriculture and Resource Economics at University of Maryland. His applied research and education program focuses on two main areas, water quality in the Chesapeake Bay and land use policies for the preservation of Maryland's farms and forests. He received his PhD from the University of California, Berkeley, and was appointed to serve on the Chesapeake Bay Program Scientific and Technical Advisory Committee, so on STAC. He also currently serves on the Maryland Stream Relief Coordinating Committee. And we are really pleased to have Dr. Newburn talk about his research today.
Well, great. Thanks so much. And obviously, thanks for the funding to support us. And I want to start by giving an overview on our team. This, in addition to myself, and I have, as I said, I'm a professor, but I also do extension, and so we're trying to, in our department, extension, where we work with a lot of faculty members like Professor Eric Lichtenberg, who's worked on many ag topics in Maryland and elsewhere, and then 3 PhD students. Derek Weidelman is currently a 5th-year student, but the other students, Young Kim was funded on this project. He was one of the primary students to do the work, and he just graduated in July and now started as a postdoc at Oxford and will be at University of Florida in the next year, the following year. And then Hao-Wan Wang has also worked quite a bit on this project, and he's now a assistant professor at the University of Miami. He was all PhD students at Maryland in the AREC department. So, we're going to talk about riparian buffers, which have been a centerpiece for Maryland's efforts in the for water quality improvements at Chesapeake Bay and the TMDL. There's also been a lot of interest in carbon sequestration and climate change and markets for that. There are many things, having served on the Maryland Stream Relief Program, there are many issues we are not going to talk about that deserve attention, but just not in our model. Things regarding wildlife habitat from buffers, aquatic ecosystems, and stream temperatures, and other things. So in addition to Hughes, that's been generous to kind of, we've been working on this project for a while, but the last year or so, integrating lots of pieces. In addition, MAIS, the Maryland Agricultural Experiment Station, provided funding for our regional survey. And then, I want to thank people that helped on our survey to provide some feedback, people from MBA and DNR, Chesapeake Bay Foundation, Maryland Extension, and Laura Pleasanton deserves a special thanks for answering many of our questions regarding the USDA CREP rules, and also for the carbon sequestration. Rachel Lamb and Elliot Campbell were invaluable to kind of get us going in using the data that they had helped develop. And this is the first time we're presenting this as an integrated. We've presented pieces in the past, but we hope to follow up with people and also get feedback on what our initial policy there would be kind of a first draft and what might be useful for the future. So with that, many people know these kind of things that Maryland and the Bay States and the Chesapeake Bay Agreement have set a goal for forest buffers at 70%, and we're falling short of that. But and this dashed line is data from Chesapeake Conservancy, and Hughes Center put out a report using 2018 data, the high resolution data, and it's probably moved a bit higher than that, but has not meeting the Bay Agreement goals. And CREP in general has been, and forest buffers have been funded by CREP and other programs. CREP was started in the late 90s, and there was an initial ramp up, kind of the low-hanging fruit. But then after that, there's been incremental progress, but not at the rate that has been needed to meet goals. Now, the Conservation Reserve Enhancement Program, which is part of the USDA and partners with the states, and Maryland was one of the first states to administer this, has been one of the primary sources. And these are long-term contracts, 10 years for grass, 15 years for forest. They become, relatively generous. They provide the installation cost, and also more recently, a signing bonus of $1,000 for forest, as well as annual payments to compensate for the opportunity cost. That said, they don't, they're not targeting directly based on environmental benefits, and have been kind of critiqued for that reason. But they have been a backbone to for adoption. And then MDA, who cannot change CREP, but they listen to farmers and heard a lot of things where they could probably get better enrollment if they had shorter contracts, or more farmers wanted more money up front rather in lieu of the payments. That their program started in 2021 and has been a parallel program where they have more flexibility to create the rules without the constraints at the federal level. Now, we actually created a survey where we look at all these kind of attributes of annual payments and upfront payments and contract length and buffer type, and we created an experiment to look at all sorts of programs, and we'll get into that. But it's kind of ideally suited to look at these two structures as well as many others. So overall, what we're trying to do is look at scenarios for environmental outcomes regarding water quality as well as carbon, both under certain payment schemes, what attributes really matter to get landowner enrollment, which ones are more effective. Also, as far as program effectiveness, the total environmental benefits achieved, but also the program cost of doing so under different scenarios, starting with just replicating what CREP does, then getting into the spirit of what the MDA Conservation Buffer Initiative is, just more money upfront. How does it change? We take money and put it upfront versus annually, as well as shorter contracts. Another thing of interest is targeting based on environmental benefits. The existing programs are compensating for installation costs and other things, but they're not, or they're giving a bonus, but they're not targeting benefits. So we're looking at, in this case, the bonus payment that Maryland offers us $1,000 and saying, well, what if we scale that by nitrogen benefits at a parcel level, and gave farmers that have higher loads slightly higher payment, and those lower than average lower payment. And then the last scenario is carbon on top of CREP. So if you had the carbon sequestration payment being on top. And to do this, this slide is really a structure of the entire presentation. So the first part of the presentation will go into the model that we're trying to estimate spatial level or a spatial variation at the farm level or landowner level for probably a probability of enrollment under different programs for forest and grass using landowner survey data. And then we have, with all this is within GIS and spatial, tax parcel level tax assessor information. So we're also modeling the site-specific environmental benefits for either forest or grass enrollment over a specific time using the Chesapeake Bay program watershed model, as that all jurisdictions use, as well as this carbon sequestration model that has come out of the University of Maryland and others that have estimated forest carbon. So with part one, as I said, we kind of go into the the survey and then some of the modeling that we do using the survey data. So this is the sample. These orange parcels are where we sent out surveys. We mailed them to these people. So essentially, we start with the tax assessor database, which is everywhere. We screen it based on ag tax code, which means that they qualify for income from ag. Then we overlay that parcel boundary with information regarding farmland from the USDA's cropland data layer, as well as the Chesapeake Conservancy layers, to make sure that they have at least 10 acres of crops or hay and pasture. We intersect the parcels with the USGS hydrology data to make sure that there's a stream or river within or adjacent to the parcel, so that these are eligible in a way to or they actually could have buffers either historically or in the future. And so that's the database. What we're doing is, we developed a survey over a couple of years. We got input from some of the state agencies, many people very involved and very helpful on the project. And then with Extension, Darren Jarba helped promote the survey, and it was mailed out summer 2021. The letter that would go out in the mail, we'd send multiple letters, but they would basically have a link to go online in Qualtrics, fill out a survey. The survey would be linked back. They'd have to type in an ID and password so that we could link their survey response back to their particular parcel. And we're sending this to the owner address, but asking them about a particular parcel. And if someone had multiple parcels from the analysis before, we would randomly pick one of those if it was a landowner had many parcels. We also allowed a option if they wanted to just get a hard copy through the mail, we would send it to them. But we started with just a one-page letter. And most people did it online. The ones who did it online, but we also did get a number through the postal mail and about a 17% response rate. So, we collected things about their historical buffers, how many acres, what year they installed, whether they got money or not, whether it was grass versus forest. We asked them about their operation, about the farm type, crops, and whether they rented or owned, what the acreage, farm income, livestock, stuff about the farmers' demographics, their attitudes regarding supporting farm programs or having government come on their land to monitor practices if they're in a contract or taking on investments. We also, because this is GIS, we can just get directly, not even from the survey, just take the parcel level information and overlay with the Chesapeake Conservancy data to get high resolution 1 meter land cover, other kind of things, as well as within the buffer area along a stream, we can look at the soil types and calculate the soil rental rate precisely, as well as other things regarding the land quality for National Commodity Crop Index, or NCCPI. So this provides some of the historic data. And what it's showing is that there's about 1,468 people that had usable data out of those that responded. And if you look at different time periods, we actually we asked them about the time that they installed a buffer. So we separate into pre-1998, which falls into the time of before CREP was widespread. 1998 to 2009, because there was a change that was made in 2009, and then out to when the survey was done. And for example, if you look at the pre-1998 buffer, what it's saying is 429 people had self-funded, and it was a natural buffer that it pre-existed. 25% got money from somewhere. And then about 1,000 didn't have a buffer at that particular time, because there's 1,400 people. So if you subtract 1,468 minus 429 of 250, that's saying there are about 1,000 non-adopters. You can look over time, and some of the trends that you get are most of the buffers on the landscape, most of the forest buffers, and even grass, existed historically on marginal land. There's natural succession. They weren't even funded. They just existed before the program. Once the program was underway, there was a lot of enrollment, but there is also still self-funding going on. People don't want to be in the program for one reason or another. And there has been an increase over time. Then if we look at all these people, if we take this data and say there's a bunch of people that don't have buffers at all, ever, either grass or forest, as well as maybe those we asked if they had some buffers, but still had other land that was suitable for buffers. We then asked them about hypothetical programs. This is what we call a choice experiment economics. It's used in marketing. It's used in many other fields of economic or different fields of economics. In our case, we're looking at alternative programs for conservation buffers. It could be that people are seeing different types of buffers. Some we're giving them an example or we're giving them different attributes. We're creating alternatives where there's 48 different combinations of these by each buffer type, where the experiment would have grass or forest. It would have either 200, 500, 1,000, 1,500 for the upfront bonus. It would have different annual levels of payment, as you can see, 100 up to 750, and different contract lengths. Other things were held constant, like the width of the buffer was 35 feet. We assumed the installation cost and even maintenance costs were fully covered, just for simplicity. And let me show you one of these 48. Each landowner is going to see 4 of the 48 and answer a yes/no question. Here's one. So what they would see is something like this, where it says there's a grass buffer, the bonus payment is 500, the annual payment is 250, and they're getting over 10 years. And then the other program is just showing that in long form, just so that they can see 10 years at 250 and really see that. But then they're just answering yes, no. And there's, as I said on the previous slide, there's 48 different versions of this. So they're seeing 4 versions of this answering yes, no questions. And we're using that type of data. We also, what we're essentially answering is what is their probability of enrollment as a function of these program attributes, like the buffer type or the level of the bonus or the recurring payments or the contract length. Do they answer yes or no, enroll yes or not enroll? And then also as a function of them, their characteristics, who is the landowner, their age, education, whether they rent out mainly or what's their percent farm income. And we have also the quality of land. We have 2 different versions. One is crop return based on the parcel level crop productivity index and other information, as well as the soil rental rate. Both produce similar results, but that's kind of what we're using in our model on the right-hand side to predict factors that increase or decrease enrollment. So these are some of these characteristics that we're using, like crop return is being used to say if this higher quality land and they enter in a program, then they're giving up, they're foregoing crop income. What type of farm is it? Is it, does it have a high percent income from farm, or high proportion of share from income from farming? Senior citizens, at least the age categorized as above or below 65. And you can see a number of characteristics about the farmer, about the operation, whether they, are willing to take on risk. Are they more risk averse, unwilling to take on long-term risky investments? Whether they've had a buffer in the past. There's a smaller number of these people, but those who have still some land that is available for buffers, but have either been funded or self-funded buffers, and participate in farm support or opposition to government involvement. For example, the last 2 statements, we're just asking them their attitudes about, should the government be able to come on your land to monitor the farm operations, or should taxes be used to support farm programs? Now, this is a regression, which is a statistical model for behavioral change. And there is actually a regression with coefficients and standard errors and all the, and from the 538 landowners who answered this part that didn't have buffers, or at least were answering this part of the survey, they answered up to 4. And so there was roughly about, 4 questions answered, or 4 program options answered. Some people only did 2 or 3, but essentially we have about 2,000 observations covering about 5,000 or 500 people. And let me go through the program attributes first. So in a econometric model, what we're basically doing is we're saying relative to grass, is forest buffer more likely? And we found that no, there wasn't a significant difference. There was a negative coefficient, but it wasn't significant. And what that's saying is that, well, there was no difference in their preference for either one. Partly, we are covering, we're the full installation cost, and there was at least not a strong preference there. With higher payments, more likely to enroll. No surprise there. Incentives matter. With higher annual payments, also more likely to enroll. These three coefficients have to be looked at together. What we're essentially doing is relative to the annual payment for a long-term contract, 15-year. If you make the contract shorter, like 15 versus 5, do you get more enrollment? We found no, that people, when they saw shorter contracts, going from either 5-year to 15-year to 5-year or 15-year to 10, there was a slightly, there was a weak effect, but it was not significant. So contract length was not the major factor. It's just the incentives level. Upfront and annual payments both had a pretty significant effect. As far as the land owner or the farm, if you have high quality land, either crop return or soil rental rate, less likely to enroll. Higher quality land is harder to enroll. People don't want to take the land out of production. Farmers that were, had higher farm income share, less likely to enroll. Senior citizens that are old, maybe they're transitioning their farm to somebody else or might sell it, less likely to get into a long-term contract. Education didn't matter. Rent was positive. That goes contrary to some of the work I know the Hughes Center and others have done. But I think what we're finding is that people who rent are interested in program enrollment. They have other barriers about learning and being unfamiliar with it, but they're actually interested in it. As far as being risk averse, those who are unwilling to take long-term risk are less likely to enroll. Those who have previously had either subsidy or self-funded buffer are more likely. Those that are opposed to, government monitoring or tax-funded programs are less likely to enroll. So this is the model, and as I said, there's coefficients that we can use to predict the probability precisely for, or at least, numerically for any particular landowner. Another model that we did, I'm not going to present it here, but I just want to mention it, which is, surprisingly, we found that 46% of the landowners in our survey, when shown 4 different randomly assigned programs, said no, 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 no. No to all 4. And despite at least one of those 4 that they saw were pretty high payment levels. So the upfront and annual payments, the range at which we randomly assigned, were quite high, and they still said no. So we were interested in trying to look at a model that separated out that first stage, trying to figure out who are those people who are unwilling to participate in any program. They're just not sensitive to payments, or there's something about their farm or other, about them, that they just don't want to do it. So a lot of I'm not going to show those, can follow up at a later point, but given the time, I'm just going to say that it corresponded what I just showed you, the kind of characteristics. And so summarizing the program attributes, buffer type wasn't that significant. Forest versus grass, we do say that the installation costs are quite different, but they're being fully covered. Upfront versus annual, upfront and annual were both significant. No surprise that incentives matter. But when we look at a more detailed analysis, the trade-off between the annual and upfront payment, it suggested that landowners strongly prefer upfront payments, kind of the way that MDA is Conservation Buffer Initiative, which is they talk to farmers. Farmers want money earlier. Taking those annual payments and turning them into a present value upfront has an important increase in enrollment. Contract length was not significant in our model. Farmers who are already participating in CREP on some portion of the land are more likely to enroll, but farmers and parcel characteristics are less likely to enroll. Higher quality land, either the crop return or soil rental rate, high percent farm income, senior older farmers, less likely to enroll. That last one is probably not a surprise to most people. Now, as far as integrated assessment, this is a whole nother set of models, more on the, we're economists, but we've worked quite a bit with these Chesapeake Bay watershed model and then the carbon model is a bit newer to us, but we're able to integrate that. So I'm going to start with the water quality. And there's a lot of information here, but I probably could have put 5 slides on this. And But this is really just using the Chesapeake Bay watershed model parameters. We're essentially starting with the landowners that we have data from. We can look at their the riparian zone, 35 feet or wider if we wanted to, and look at the amount of land that they have that would be available, being cropland. It could be converted to forest or to a grass buffer or other things. The other thing we can do is, what we're doing essentially is estimating the nitrogen and phosphorus loads for either forest or grass over any of this contract lengths, 5, 10, or 15 years. And I'll kind of use forest 15 as a baseline to talk about that as an example, but we've done it for all the combinations that are available in our survey. The Chesapeake Bay watershed model, for those who don't know, it has, you start with the amount of load that comes off cropland versus when you go to, say, a forest buffer, there's that differential. There's the buffer efficiency rate, how much the buffer removes and how that changes over time, as well as once the load gets in the stream, how much of that gets to the bay. And when I say direct and indirect benefits, direct is within the riparian zone. So if there's an acre of cropland and it's converted to forest, you're no longer fertilizing. There's a direct effect right there. But there's also indirect effect that as that buffer grows, it indirectly filters from the remaining cropland. And the BMP practice efficiencies, these are coming from Belt et al., which is the Chesapeake Bay's panel of experts and other people that help to inform that. And as far as quantifying the benefits of this, there's a social cost of pollutant loads that's been estimated by a study in the Chesapeake Bay researchers at Penn State. And we're using that. So it's kind of taking the water quality benefits estimated physically from all the information above, and then multiplying that by the per pound social cost, and then looking at that for every year, say a forest buffer year 1 to out to 15, and discounting that over the 15-year contract. There's a lot more nitrogen. The nitrogen benefits are much more than the phosphorus benefits. So there's per pound social cost of phosphorus is about 2,207. Nitrogen is only 17, but there's just a lot more nitrogen that is being reduced from forest buffers. A lot more nitrogen in the system relative to phosphorus. So this shows for the landscape what that model produces for a 15-year forest buffer. We're not making any assumptions on our own. We're using the data of the Chesapeake Bay watershed model. So discontinuities are things where the hydrogeomorphic range, hydrogeomorphic region changes here from tidally influenced to upland, or here the reservoirs in Baltimore, like Pretty Boy, Liberty, and so on, so are affecting the nitrogen delivery rates. But this is kind of where how the distribution of nitrogen varies according to the model. Now, carbon is a newer thing to us, but it's a really interesting product. I think people should be looking at. Developed it for Maryland and then expanded out to the RGGI states, the northeastern states that have the Regional Greenhouse Gas Initiative. And Rachel Lamb and Elliot Campbell and a number of really good geographers, both in Maryland and elsewhere, helped to pioneer this in Maryland and then moved it elsewhere. And it starts with initial tree canopy and biomass from remote sensing data, LiDAR data, at kind of sets initial base. For our information, we're starting with land that is cropland and growing it out. But there's this ecosystem demography model that essentially for every pixel incorporating the spatial variation in weather and soil, can model the forest carbon sequestration from years 1 out to whatever number of years. It's at a 90-meter move down to 30-meter level, and we can do that for our parcels. Every single parcel, we can get this above ground biomass for forests over a contract length that's specified. Let me say, we don't have below ground biomass. So there's a caveat that we're just looking at above ground biomass, and we don't have information for grass. So, and there's rules of thumb for above ground versus below ground. We could incorporate those at a later stage. For grass, we don't have a model, but just put those out as caveats. The same idea as far as environmental benefits. We're using the social cost of carbon. something developed both by economists as well as the EPA to discount. This would be for permanent storage. If you took carbon out, a ton of carbon forever stored. And obviously for forests, we're just looking at it for the 15 years. So it is actually, lower because we're just looking over the contract period. And essentially we're taking the physical carbon modeled over, say, a 15-year forest buffer, and then multiplying it by the social cost of carbon, but only accounting for those 15 years. And that's kind of the basis of what we're doing to calculate the environmental benefits of carbon. So this is showing the physical model where carbon varies. So I think, for example, in Western Maryland, it incorporates spatial variation in temperature, weather, so cooler climates, shorter growing season. Also, a little bit, the soils are not quite as deep, and so there's lower growth rates for carbon here than maybe some of the elsewhere. So, as I said, with the policy scenarios, we're essentially CREP is we're starting with CREP in a this is the CREP scenario, and this is what we call like a baseline scenario, which is replicating CREP. And the forest buffer contract is 15, grass is 10. The annual rental rate is the soil rental rate times a multiplier. The installation costs this is coming from UMC's report corrected for inflation. And then the signing bonus is the new signing bonus for forest is 1,000 and grass is what it's been before. And then from that we can look at for say forest 15 years under this scenario, we can look at of the 500 landowners, what's the probability that they participate, the participation rate of those people, what the for those that participate are weighted by their probability, the total environmental benefits as well as the total costs, and try to evaluate the program as such. This is the soil rental rate. So, we have the soil data down to a parcel level. We can look at within the riparian zone and get the 3 dominant soil types, and then use the soil type to soil rental rate for those particular that particular parcel. Basically it's the weighted soil rental rate by the 3 dominant soil types on any parcel. And you can see obviously like Queen Anne's County or the Upper Eastern Shore is higher than other places. So with the scenarios, what we're doing is we're starting with CREP, and then we start with a couple other scenarios. For example, CREP, that becomes our baseline model. Then we're actually just modifying CREP. So these are in the spirit of MDA, but we're not the Conservation Buffer Initiative, but we're decomposing. So we're taking the CREP baseline, and then saying, well, if you took these annual payments and converted 15 years times 3 at 3 times the soil rental rate, 3 times the soil rental rate for 15 years, and turn that into a present value and put it up front, we're looking at that. As far as the contract length, we're looking at CREP for these, 15 and 10 year, and then this one is looking at it saying, well, what if we only did that for a 10 or 5 year? So in other words, if we want to look at one feature at a time and decompose it, because if we change 3 things or 2 or 3 things at the same time, it would be confounding. So just to let you know that these actually are, we're modifying CREP to kind of have it, all referenced to this baseline. As far as a targeted scenario, what we're doing is taking just this $1,000 and saying, well, let's scale it by the nitrogen. So if you were to say the average person would get 1,000 based on the average amount of nitrogen on per acre would get 1,000. But if a landowner had a higher load and possible higher load reduction by putting in a buffer, say they were at 1.5 times or 50% higher, they would get $1,500. If they were 20% lower than average, they would get $800. So it's kind of just scaling that based on the achievable nitrogen, using the average getting $1,000. And then the last one is looking at CREP, but adding a carbon payment based on the regional greenhouse gas initiatives, carbon trading prices, and the model that showed how much carbon was being sequestered. So let's start with the baseline, and it kind of walked through these different outcomes. So what this is saying is about 16% of the landowners, given, say, a forest buffer 15 years, but 16% would participate. The benefits for nitrogen, phosphorus, and sediment would be about 2.3 million. The cost to pay those PrEP contracts would be 1.23. And the net benefits minus cost is net benefits, or the ratio is benefits divided by cost is the benefit cost ratio. Most of the benefits coming from nitrogen. Carbon's very little. The amount of carbon that's sequestered in the first 15 years, as well as we only, it's not going to be permanently stored, it's quite small. If we go to the upfront payment, the idea of paying farmers rather than annual payments, pay them upfront, huge increase in enrollment. This is 16 to 27%, but that's a 70% increase in enrollment relative to the baseline. Now, the benefit cost ratios, you're not targeting better, you're just getting more people. Because this isn't scaled based on an environmental benefits, it's just getting more people in the landscape, but a really huge response. Probably the easiest way to increase enrollment is give people the money up front. If you do a shorter contract, you get the lowest outcome as far as the benefit cost ratio. You're basically spending a lot of money. The costs are pretty similar because you have to pay people to install, but you don't have as many years to recoup. All these are 15-year contracts, except this one is a 10-year contract. So you have the initial cost, but only 10 years to recoup benefits. So you're just not getting that many benefits. So that has the lowest benefit cost ratio. Targeting is a modest increase. It has the highest benefit cost ratio, but let's be honest, we're actually only targeting the $1,000 and maybe giving people an extra 500 or 200 less. Most of the costs are the install cost, the soil rental rate. We're not changing those. And so this is a very modest targeting. We'd be open to scenarios that I think what would be realistic, because I think we try to be conservative on the scenario we did. With carbon, you get a little bit of increase. You are giving people more money, but it's not a huge payment. And the next slide will show that even more. So this is what's interesting about carbon. If you do a back of the envelope calculation, you only get the trading price about $35 per ton. That map that I showed you, the average person was getting for carbon was about 38.38 tons. So the payment of $35 a ton times 0.38 tons is about $13 a year. That's the annual payment. You compare that to PrEP, where the soil rental rate on average is about $77. A forest buffer gets 3 times that. This payment is not even close. And if you basically take this, the present value of this for 15 years, that's about $170. You take the present value of getting $231 every year for 15 years, that's about $2,900 when you look at present value discounted at a 2.5% rate. And the other thing is carbon's not even getting any money for installation or signing bonus. So if carbon trading had to compete with PrEP is way more generous. This is a very generous program. And not just that, we really pay a lot for buffers compared to, say, if you looked at whole field contracts to plant forests in CRP or maybe in cover crops. It's very different. Carbon trading might have inroads in other practice, but in compared to PrEP, it's one of the more generous programs. Another thing is, if we start looking at the magnitude, that's about $6,000, about half in this upfront, and then half the discounted rent. Look at this. I'm going to dig down on the targeting part, the targeting idea. So I showed this targeting scenario here, and I want to show you what we're essentially, the assumption being made in that model is that on average, people are getting $1,000. If you had 1.5 times, so this is showing the distribution of end loads, scaling it so that the average is 1. So what this says is our assumption in that scenario was that if someone has a higher end load reduction, say 1.5, they would get 1,500, an extra $500. If someone was at, say, 0.8, they would get $800, $200 less. So that money, an extra $500 or $200 is very little compared to the set of payments that are being offered. So that scenario is a very modest scenario. We'd have to be much more aggressive about targeting. Grass, I'm just going to say there's similar trends. If you pay people up front, a lot better enrollment, shorter contracts, lowest benefit cost ratio. Targeting would matter if we vary those payments more, but essentially, and again, we don't have any carbon benefits for grass, but one of the things, the benefit cost ratios go up in general compared to forest because it's just not that expensive. We're not giving them as much for the install costs or the forest or for the bonus payment. So the benefit cost ratio for grass is quite high, but they don't achieve the same per acre benefits. So the take-home points are this: upfront payments are strongly preferred to annual, increase enrollment. The shorter contract periods, they're about, they maybe a slight improvement in enrollment rates, but not significant in our model, and fewer years to get the benefits back. So that's actually the worst outcome. Targeting bonus payments does get the highest benefit cost ratio. Other payments don't even look at benefits. They're not really targeted. They're based on things like either a uniform payment of $1,000 or based on soil rental rates. Soil rental rates are not highly correlated with nutrients. So but there's room. I think the discussion would be good to know what might be more realistic. Carbon offsets, I'm sure they're going to work in the ag sector. I think CREP is probably, not one of the places where they're going to be a game changer. And at least that's kind of our initial thing. I'm going to skip this slide just for, it's a different project. And I just want to go to the discussion and say, we expect to have a draft report available next month. I think when there's an email with the recording of this presentation at the end of October, we'll distribute a report. It's about 20 to 30 pages with all the details. And I hope to follow up with people and have smaller group meetings where maybe we could get into some of the details and hopefully have a good discussion. But I hope to have additional ones now that we have the model up and running and can really take feedback from stakeholders both today and in the future, and on a number of things. And you can contact me directly, find my website, and I'd be look forward to the discussion. Thanks.
Thank you very much, Dr. Newburn. That was really informative. I was surprised to hear how big the difference was between CREP payments and potential carbon trading. I had never thought about it that way before. That's very interesting.
Yeah, we did not either. I mean, to tell you the truth, we wrote the grant and carbon was new to us. We were kind of promising it without having had the data. And then once we started working with the data, we just did that back of the envelope calculation. We saw that and we realized, and we're still learning. There's different ways of accounting for benefits and what would happen after the contract and re-enrollment. How should you restructure re-enrollment? And young Kim, who's one of our postdocs, is even trying to figure out a project on that. But I think the bottom line was, we were surprised at that it wasn't going to be comparable. And once you started thinking about Maryland and other states have only increased their CREP payments over time, and buffers are such an environmentally sensitive area that it makes sense to make high payments. And most of the benefits are not on farm. With cover crops, there are a lot of on-farm benefits of soil health and so on. So with buffers, not as much. And so the payments are quite generous to do that, but then it makes it hard to. We actually have another paper which is we looked at carbon trading stacked on top of water quality trading, and having water quality carbon competing with CREP, and CREP outcompetes both. And that's not even getting into, well, we know with water quality trading, there's all these barriers of like finding, figuring out about the program and figuring out how many nutrients are coming off your land, and then setting up a contract, and so on. So water quality trading isn't taking off. Well, carbon would have some of the same issues, at least on a first cut.
Interesting, yeah. So just a reminder to everybody that this session is being recorded. We had, and feel free to raise your hand or to ask your question in the chat. We had some questions about definitions of a grass buffer. And I think you can correct me if I'm wrong. They were from Mark Imlay. I think that they are related to like the requirements for signing up for the program. And they were about, let's see, if the grass, if I think the main question was if you have to plant a native species in grass buffers, and Ruth Castley put a link in there. I don't know if that's something you want to address, David, or just refer him to the the best management practices that are linked in the chat.
I think it's probably best to look at the link. I mean, you know, for us, we're just taking, you know, for example, the Chesapeake Bay watershed models parameters based on grass, and we don't have the ability to say, if you plant this species, the nutrients are this. If you plant that species, the nutrients are that. Our model doesn't have that level of granularity. I did see a chat a thing pop up, which someone said, are the presentation slides available? And I shared them with Elizabeth and Josh. And what I would say is, if you want to just put that a link, you know, the PDF, I'm sorry, the PowerPoint presentation that I just shared. If you want to just put that in the chat, the slides are final, and glad to share them and follow up with people.
Thank you.
Yeah.
Great. Great. Okay. Yeah, we got some thumbs up on that. I don't know if anyone has their hand up. I am not seeing it here. I do have a question. Maybe I'll get it started. So, let me ask my question first, and then I'll go to you, Mark. I see that. I know you talked about how upfront costs really increased enrollment, and I know you've done some work, I think, on the dropout, like how dropout rate of these programs. And I wonder if you just make some brief comments about how, you know, if you incentivize it by increasing upfront costs, like how might that impact, you know, say dropout rates, or you know, like if a farmer dropped out, what would happen?
Well, wait, say the question again, because I want to make sure I get it right. Just say
Yeah,
it.
so you know, I assume that there are a certain percentage of farmers that don't stay in the program for the 10 or 15 years, whichever is required. And so if you incentivize by giving upfront costs, I'm sure that the program, you know, that there's some requirement now that if you drop out of the program, something happens to you. And that would almost have to change if you incentivized it with upfront costs.
Well, let me actually share the slide that I skipped, because I think this is kind of where it kind of goes to this point. So we have a whole nother project that the Hughes Center partially funded, and we published more in an academic journal. And let me start by saying, what that project was about was payments and penalties. So when you do a contract under the USDA, the standard penalty, and this is both in the US and the UK and all these, you know, other countries like Costa Rica and Australia, and everybody does this, where they say, if the landowner doesn't complete the contract, say a 15-year forest buffer, they must pay back, you know, the installation cost, the bonus, and any annual payments and interest. And so we were thinking, wow, you know, this came out of a meeting that we had at MDA. We were just talking about their goals, and they're trying to increase payments. And we thought, wow, if you increase payments, you'll lead to higher enrollment, but that'll also indirectly increase penalties, and that'll inhibit enrollment. So then we thought, okay, well, and forest buffers are getting more challenging because we are increasing payments, and that's good. But there's this secondary effect, it's smaller, that reduces that. And even the physical cost of buffers, the roots get established. So we actually created a whole model that decoupled that, said, don't structure payments, penalties based on payments. Make them, what would you, if you didn't constrain it to be that way, what would the penalties look like? And they actually are more about the benefits that you don't receive by getting out early. So our model, our recommended structure is to decouple payments and penalties. Now, that said, that's not going to happen anytime soon. So if you increase payments, what's more likely going to happen is, I mean, one is it's to some degree, it's inhibiting people from even getting in the program that are on the fence. The people that might think, oh, I might get out. I know I have this penalty if I might get out. They might not get in the program. But once they're in the program, they're kind of, they're less likely to get out because they're going to have to pay this big penalty. So it's kind of more likely to inhibit them on the front end. That said, we found that there is maybe somewhere between 6 to 8% of people that drop out of these contracts, and they end up paying that standard penalty. So it does happen, especially with a crop price increase with the Ukraine war and crop price increase. Those are events that kind of create that shock that people didn't expect that and get out early. So it is an issue, and we have a whole nother paper. I think this is probably not the time to get into the details, but essentially it has to do with that idea that payments and penalties are tied at the moment in all programs.
Thank you. Mark, I think you had your hand up first.
Yes. Speaking of grass buffers, it does not include Japanese steelgrass, of course, right? If it's 100% Japanese steelgrass, I don't think that counts as a grass buffer. But my other question is, I want to pass on, when I was a natural resource manager in the federal government and I was a park ranger, we found that if you include native plants with a deep root system, has many niches that holds the water and releases slowly. It's a major tool to save the government a lot of money to deal with stormwater runoff. It holds the water and then releases it slowly. So I want to share that tool. Make sure that it has a complex niche root system, so it holds the water and lets it out slowly. And my question, you're not including Japanese steelgrass, a patch of that as a grassland buffer, right?
Yeah, we're not. I mean, we're not. To be honest, we're just not getting into that level of like species level. We're taking more, whatever the scenarios within the Chesapeake Bay program model that they're defining as grass, or at least some combination weighted average of what they're defining as grass, and not getting into that level of variation of grass. Or same thing would be true with forest. And so,
yeah, thanks.
And
Thanks.
you got my practical point.
Yeah,
Works so well to hold the water and release it slowly.
Yeah, thanks. I'm going to read a comment from Rob Schnabel, and then Eric and Don, I'll get to you right after that. So Rob said, great presentation. He wanted to know if there was plans for expanding the study to include other ecosystem benefits in the future, such as water quality, given climate change and water quality becoming more important, reduce flooding, help baseline during dry periods, or something like that.
Oh, I'll just clarify. I meant water quantity, not quality, but quantity. Just given climate changes. That's fine. That's his presentation was a quality, so I just wanted to expand to quantity issues. Thank you. Sorry.
I think in the short run, we're going to try to work with the model that we have and try to get feedback on, trying to do more realistic scenarios that would help stakeholders, and we'd be glad to follow the Chesapeake Bay Foundation or any other groups and smaller groups. I actually, it's been on our, we've been trying to get ready to do that, and now we're finally ready. And so I hope to follow up. As far as water quantity, I think we would need a new grant and a whole new thing, and that would take, so I would say we'd have to get a whole new grant and develop that, and that wouldn't be an easy add-on for the type of stuff we're doing, but it does sound interesting, and issues of climate change and resilience, and those kind of scenarios of how those are front and center in issues like the STAC report and other become they're leading science issues.
That'll just end up adding to your incentive payments right off the bat so much higher, since a lot of counties MS4s are pushing for stuff. But I think that dollar amounts and upfront payments will increase a good bit. So that's it for my question. I see there's other people who have questions, so I'll stop. But that would be really great to have that at some point. Thank you. Great presentation. Thank you.
Thank you.
Yeah, thanks. Eric, I think you had your hand up.
Yeah, hi, Kate. I just wanted to make a brief comment elaborating on Dave's answer to your question about people dropping out and what converting everything to upfront payments would do. Basically, nationwide, the rate at which people are dropping out of these kinds of programs has been growing and hitting around 10% these days. Qualitatively, what we found was that if you decouple penalty for premature termination from sign up, the thing to do is essentially front load the penalty, which kind of keeps people in the program longer. And so converting everything to upfront payments is a great deterrent for dropping out. It sort of conforms qualitatively to what our optimal penalty was.
Interesting. Thank you. Thanks, Eric. Don?
Yes. First, Eric, I like your New Orleans Sewage and Water Board shirt. That's my hometown on your T-shirt there. Dave, many of these funding sources are tied to certain purposes. So, for example, the IRA, the Inflation Reduction Act, includes really massive investments in agriculture to reduce greenhouse gas emissions.
Mm-hmm.
So they may well be these funds, you have to be able to demonstrate greenhouse gas emissions. So the question then becomes, in agriculture, do you use those funds? Are they more optimal in terms of co-benefits as well as greenhouse gas reductions, to spend it on, soil sequestration in cropland or in forested buffers? So what I'm saying is that the funding comes from that source. You have to demonstrate that the benefits in terms of reductions, of greenhouse gases, but they're co-benefits with respect to nutrient capture and so on. So how do you integrate that when you have the funding? It may not be very effective if it just comes through CREP, but if it's there specifically for greenhouse gas reductions, can you get then co-benefits for nutrient removal if you invest it, say, in buffers?
Well, to some extent, that was one of the motivators. We started really with a project about buffers and nutrients, and then but the RFP also had an interest in carbon, and we thought, wow, we could add carbon, a lot of interest. Now, but it came to that thing that the carbon benefits, it really comes to the assumptions that you have about what happens once the contract is over. If you assume that buffer is going to stay there forever and you don't never have to pay the farmer again, or maybe you pay them less, there's a lot of open research for re-enrollment and optimally setting those contracts. And a lot of people, I won't get into it, but there's research about that to some extent. I think that would be needed for the carbon benefits, at least according to our model, to increase substantially. At the moment, those co-benefits from carbon are relatively minor. But that's not to say that's to say in our system, in the riparian buffer, the nutrient benefits that are coming out of our system, their carbon is low compared to nitrogen. But I think that I would not say that universally true. And so I would say looking at different practices, looking at different regions, but in our context, the carbon co-benefits were a small fraction. I think you got muted. You're on mute. Yeah.
I'm trying to,
Yep.
I'm asking the question in reverse. You have to spend this money on carbon benefits. Can you also get, is it optimal to do that in a way that gets nutrient benefits?
I guess what I would say is that you wouldn't spend carbon on this practice. If you started with carbon, you wouldn't spend it on buffers. You know, there's no entryway. I mean, actually, that slide that showed the back of the envelope calculation shows that carbon trading, and that's carbon markets, what you're willing to pay, but the benefits as well, do not compete in the land of buffers, and that it would be in some other practice. So I think there's a lot of interest in that, and we were interested in that, and we wanted a paper to show that, but we knew it didn't.
Okay.
And I think that's kind of, at least
We
in our.
found one practical way to keep people on for decades is to lowering their property taxes lowered. So let's keep that in mind, how much their property tax went down, and as long as they keep their buffer, the property tax stays a little bit lower.
Yeah.
So thanks, David. So we're actually at time, but Mark, both Mark Szymborski and Mark Imlay have had their hands up for a time. So let's just take these two last questions before we end. Mark?
Yeah, a couple questions. One is, would it be possible to subset the study results by a specific watershed?
Yeah, I mean, we don't have a lot of, you know, you saw some maps that showed, you know, 10,000 landowners, but we actually have, you know, we only have 500 people that actually responded to our experiment that we can actually model like what they're doing. So what I would say is, we can do some analysis by sub-watershed and other things, but it depends on what granularity you're talking about. And
Okay.
actually, we could, there's things we could do, we'd have to get into what assumptions you could make and so on and so. But there are certain people that responded to a survey. We have the environmental benefits and all sorts of things everywhere, but we only have landowners, their characteristics of the landowner in certain areas. But we also know how they respond to certain program attributes. So there's stuff we could do. We could definitely do stuff, but with certain you know, with certain caveats.
Okay, because I'm doing a buffer benefit study, buffer restoration benefit study in the Patuxent Reservoirs watershed, which is the upper part of the Patuxent Reservoir. It's the part that's in Montgomery and Howard County. So I could talk to you offline about that. And then the other question was, in Montgomery County, one of those slides, it looked like there's something of an inverse relationship between the nitrogen benefits and the carbon benefits. In the Patuxent watershed in Montgomery County versus the rest of Montgomery County. I don't know if you had any idea of why that might be.
Well, that's it. One is I'd love to follow up with you, and anybody who's interested in following up with other, you know, either in any way, whether a long meeting or go visit or so on. So anyway, but let me say that we did look at the correlations between nitrogen, phosphorus, and carbon across the landscape. We found a negative correlation, modest, between nitrogen and carbon, which means if you pay for nitrogen only, you'll get slightly lower carbon benefits. But it wasn't that, you know, it wasn't like perfectly correlated in any way. But it is, at least it's not, you know, what you want is that you pay more for nitrogen, you also get more carbon, but when they're positively correlated, nitrogen and carbon. But we'd have to dig in. I mean, we could probably look at the maps and start showing where there's positive and negative correlation. I don't know about the Patuxent in particular, but at a Maryland level, there was a slight negative correlation.
Thank you.
Thanks, Mark and David. Okay, so Mark Imlay, do you have again? I hate to cut off questions, but we're over time. So if you have another question, please share it with Mark, or Mark, please share it with David. Mark, you are muted. There you go.
Well, as I mentioned, if you can respond about one of the best tools we use, like conservation easements and so forth, is how the property tax goes down. So people want to keep doing this every year if they know their property tax is going to stay down quite a bit.
Yeah, there's a whole nother thing, which would be the difference between a short-term contract of 10 to 15 years versus a long-term easement, undercrop even, for a permanent buffer. We didn't have that as part of the, policy analysis and within the survey. So we didn't able to look at questions like long-term, permanent easements or re-enrollment. Those are all really interesting ideas. And we just had a survey that tried to limit to, to the kind of standard contract. But I totally agree that those are very relevant.
Thank you. Well, David, I want to thank you again very much for this presentation. We had at the peak, we had a huge number of people who were watching. And there was a question in the chat about the recording, and Josh has said that the recording will be sent out by the Hughes Center in October to people who registered for this presentation, but that in addition, it's also going to be on the YouTube channel, the Hughes Center YouTube channel. So you can look at that probably in advance even of us sending it out to you. So thank you again, David. Really appreciated it. Outstanding information. This was really good.
Thanks, everybody. Really appreciate it. And please contact me. I hope my name, if you just Google me at University of Maryland, College Park, you find my email and send me an email. I'd love to follow up with people in more detailed conversations and learn more about what you're doing, your interests.
Thank you.